I'm here to introduce Curtis Wilson. Hopefully I just said that right.
Yeah.
And he's going to give you an excellent talk on how to not lie with data visualizations. You know, probably, that data tells stories, but sometimes it can tell fairy tales. So he's going to tell us a few stories of how it can trick us and hopefully make us better knowledge on how to spot them. So without further ado, I'll lead it on.
Thank you, Rachel. Okay, so Rachel has said it's going to be an excellent talk, so hopefully she's right. We'll all find out together. So a bit about myself. I've been working in data for over a decade now, doing a master's in statistics and applied mathematics, then eventually joined PwC, where I spent most of my time making dashboards, before eventually doing more exciting things like sentiment analysis and predictive analytics around predicting how weather forecasts affect car wash sales, which fun little projects here and there, before I eventually thought, no, I want something a bit deeper, something to sink my teeth into. So I joined White Hat as a data scientist, where we use deep learning to verify vulnerabilities using a technology called BERT, which is like a proto LLM. So we were doing LLMs before they were cool. But my day-to-day was mostly around risk and analytics. Customers had hundreds, thousands of vulnerabilities spread across dozens of applications, and they needed to understand what they should do, how they should prioritize things. The common theme here is taking large, complex data sets and simplifying them into nice little pretty pictures. But every time you simplify something complex and big, it gets easier and easier to leave out important details, knowledge, and context that essentially turns your simplification into a lie. So that's essentially what I'm going to talk about today. How simplifying things can make things a bit more, more of a lie. So this is what we're going to be talking about. I'm going to open up with an example of a chart that was made with good intentions and then befuddles everyone who looks at it. We're going to talk about how visualizations mislead people in general and sort of skirt around the edges of some interesting psychology without getting too deep into it. We'll explain why simple rules that people teach you in Data Visualization 101 aren't enough to actually tell truthful stories. And then eventually we'll end with some of the underlying principles that I use to make sure that my visualizations aren't misleading people. Just start with what I'm calling the beautiful mistake. I do want to preface this by saying that this was designed not to mislead anyone. I think it was designed with really good intentions to create a very strong visual argument for the point they were trying to make. Does this work? Yeah. But it's an example of where visual storytelling overtook clarity. So this was created in around 2013, I believe. It's gun deaths in Florida. It's a fairly well-known chart these days, used as an example in a lot of these sorts of talks. It shows the number of murder victims from firearms in Florida from about early 1990s to early 2010s. In particular, it highlights in 2005 when Florida enacted the Stand Your Ground law. And the effect of this was that the number of gun deaths in Florida rose. Rose because 0 was at the top. And the numbers increase as you go down. Which was a design decision chosen because what they wanted was this visual metaphor of dripping blood. And so more blood means more death. Except that every single person who's ever made a chart knows that line goes up means the number goes up, and line goes down means number goes down. I think it was driven by creating this really interesting visual, but completely reversed the meaning of what they were trying to say. It was good intentions, but the people who looked at this completely misunderstood it. Every time I look at this chart, I have to remind myself quickly that it's the wrong way around, because it flies in the face of every convention we have around how charts and graphs should look. These conventions have just been baked into the language of what we now understand as visual data. And our brains fall for this. when we look at a chart, we see things before we even notice we've seen them. And this is what I want to talk about in why visualizations mislead. Misleading visuals come from how people see charts, not how they think about them. A lot of charts tend to fail when we ignore human cognition and we ignore what our audience knows before they even look at a chart. So, oh God, that's actually so hard to say. I'll tell you this looks a lot better on my laptop. What I want to talk about here is pre-attentive processing. It's the idea that our brain notices things before we consciously think about them. The example I wanted here is, if anything, this makes it even better. The task is to count the number of 4s. It's difficult, it's hard, but if I do this, it becomes trivial. I hope, yes. This seems almost banal. Like, yes, obviously if you make them a different, darker color, they jump out at you. But it's worth noting that to a lot of machine learning things, this isn't actually that much more difficult. You know, computer vision, if you have a AI that can take visual pictures, it would find both tasks just as easy. But humans are designed to see color. We see size, we see position, we see orientation, we see motion. Understanding how humans see color in terms of visual data could be an entire talk in itself. One of my favorite examples of this was an experiment where they had seals of limes and lemons. And they found that if the lime data was colored green and the lemon data was colored yellow, people found it very easy to interpret a chart. And if you did it the other way around, people found it incredibly confusing. Because they just intuitively know what each color is meant to represent. Another fun one, and again, this is getting into how deep you can go with this sort of thing. On each side of this diagram, we have shapes. There's 4 of each, so like you see 4 squares. If I ask you to find like the 4 diamonds, find the 4 triangles, find the 4 circles, it shouldn't be too hard. But if I go over here and ask you to do the same thing, like find the 4 moons, or find the 4 window panes, it becomes a lot easier. It's faster because these shapes are considered, they are perceptually further apart. And so as shapes, they're easier to distinguish. And I'll give a reference to a paper at the end by Franconeri, I believe it's called like The Science of Visual Data Communication, where people go deep, deep into this kind of design. I don't want to go too deep into it because I could end up just spending the rest of the talk talking about that, and I won't talk about other things. But this idea that we perceive different visual encodings as meaning different things, as helping us understand different things. As a quick example, angle and area are good for big, simple contrasts, but we struggle to tell small differences apart. Whereas if you have position, it's really good for very precise comparisons, but it's actually harder to tell bigger ratios. So you'd use, say, I don't know, a pie chart for if you want people to know that certain things are 4 times bigger than another thing, but use a scatter plot if you want people to tell the difference between 2, 3, 4% differences in value. But they can also be used to mislead people very easily. Take, say, grouping proximity, which is really good for recognizing clusters of things. If you put certain data points beside each other, people will start to believe that those data points must be related in some way because you put them beside each other. Why would you do that if they weren't somehow meant to be interpreted together? You have to understand when you're creating visualizations that your viewer forms a conclusion before they even read anything you wrote down. And we'll get to some fun examples of that, but this is I think, perhaps a final good example of how you do data visualization before we get into all the bad ones. You can take really simple data that I just made up, and by doing something very simple, highlighting the color, you pull out stories, you pull out data, you tell people what they're meant to interpret from the story and you say what the argument is. You say, for example, here, there's a strong recovery. That information was here, but it was obscured because it wasn't highlighted. It's, like I said, this is data visualization 101 stuff. Let's go into some more fun examples. This was from Trump's Republican nomination last year, 2024. What he wanted to show was once he left office, the number of illegal immigrants skyrocketed. And what I want people to take away from this is charts have an authority that text doesn't. Because they are rooted in numbers and maths, people tend to believe them, or at least believe what they're trying to say. We see things like arrows, we see lines going up, we see what the story is trying to be. If you show this to someone who is very anti-Trump, we can start talking about why all of this is not really anything to do with Trump a lot of the times. But what most people don't notice straight away is that this is not the date Trump left office. He left here, early 2021, not March 2020, which is when COVID happened. So I have no idea why they labelled this way. Well, I do. I have ideas. But one of the things that I find really interesting about this is these pre-attentive processing, this idea that you saw a visualization, a diagram, and your brain began to interpret what it meant before you even started thinking about it. People don't immediately realize that this data is wrong because they believe that the underlying data should at least be trusted, but it's interpretations that are wrong. So that's one of the ways that pre-attentive processing can get really kind of nefarious. Another fun example where the underlying data is, at least to my knowledge, correct, is this one about climate change, showing the proportion of man-made CO2 as a total of the whole atmosphere. It's using a lot of the same pre-attentive processing things we talked about: shape, color, drawing your attention to tiny little things. It's then putting this argument over the top of it that this is not important, because we tend to think of small things as being less important than big things. And so by putting it in the wrong context, it creates a misleading argument. But again, it's hard for our minds not to immediately notice how small this is, because it's something we are trained to understand as being important. It's another fun one. This is so many classic tricks. The fact that it's restricted to a very now time frame is interesting. I guess Labour could only get away with this in January 2025 because they can use 6 months on either side as a comparison, and means they can ignore what was maybe happening over here for the last year or two, because waiting lists were declining already, and then they saw the normal sort of winter bump, and then they come down again. It hides the y-axis. There's no numbers on any of this, completely removing all context. But it also does a fun thing with color, which is worth noticing. In almost every other context, blue means good and red means bad, except in the context of UK politics, when blue means Tory and red means Labour. Which is one of those, again, I said earlier, you can talk a lot about colour. People will talk about how we interpret colours. How we interpret colours also changes depending on context. But this is one of many examples of people use charts as visual arguments all the time. It's one thing I think whenever you see a visualization, you should always be thinking about is what argument is someone trying to make, and what are they trying to convince you of. So I guess the next question is, how do we avoid doing it? I said that title talk was how not to lie. So I guess, how do you avoid creating charts that mislead and confuse people? In a nicer world, the answer would be you follow a bunch of rules. But a lot of times, if you follow rules, all you'll end up doing is creating prettier lies. So, for example, one of the rules you see people say all the time is never break the y-axis. That y-axis should always start at 0. So this is a real example from the National Review in December 2015 of average annual global temperatures in Fahrenheit, and they were very good and started the axis at 0 degrees Fahrenheit, which that also argues a mistake. You should start at 0 degrees Kelvin if you're doing this with temperature. But in so doing, they show that, you see, it hasn't risen that much. By doing 0 degrees Fahrenheit, they completely flatten out any relative change and create a much more misleading diagram. By obeying the rule, they managed to obscure the story. And their argument was that everyone who only chose temperature, the temperature gradient in this kind of area, they're the ones that align because they're breaking the y-axis, and we all went to school. You should never do that. It's like the takeaway here is that rules prevent mistakes, but understanding prevents misrepresentation. You need to know when you should or should not break the axis, how much you should emphasize changes, because it depends on context and what you're trying to show. Here's another example. It's always sort by size, which I admit does tend to create prettier looking diagrams. But a lot of the times it comes back to what I said earlier about the grouping. When you put things together, it invites comparison. It's by putting these languages together in web front end, it invites you to compare them to each other, which is much more useful to people because if you're comparing programming languages, you probably are interested in how they're being used. So when you're sorting things, you have to actually understand what your audience is going to do with this information. Because a lot of the times they don't just want a list. The final one is remove chart clutter. I'll get into something else now, but there's so many of these rules, and all of them are wrong. This is from the Competition and Markets Authority, which they decided to remove a lot of the chart clutter from this diagram, including the y-axis, which they decided was just getting in the way, I assume. Which in turn removes a lot of context here. In particular, because you have two different groupings, there's no way to tell what the relative size of these two bars are meant to be to each other. It's, again, for example, am I meant to interpret that the number of app developers is bigger than the number of native apps in the App Store? I don't know, because these are two separate graphs that are put beside each other with no context around relative size. This is true for every rule, like I said. If you just follow them blindly, you'll just create nice-looking charts that still don't tell you the truth of the matter or what's actually going on. Again, colors like weird. So this is from Roberto Cairo, who wrote How Charts Lie, which is one of the inspirations for this talk. It reminds us that design is about meaning, not style. You must figure out the structure of your data first, the structure of your graph, and then figure out the aesthetics. So following rules isn't going to save us. What we need to have is understanding. And let's get into the last section here, designing for truth. So we've seen how charts can mislead people. The final section I want to talk about is how we go about creating charts that actually tell you the truth of the world. One of the things you have to do is understand the data, which is annoying because it's difficult. I say interrogate the numbers up here. This isn't just create a few pretty statistics, a few pretty simple graphs. You need to actually understand where your numbers come from, who created them, why are they there, what do they actually mean. You have to ask what's missing, uncertain or assumed. For example, one of the big issues we have at Black Duck is that we have a mix of SaaS and on-prem products. With our SaaS products, we have tons of really interesting data. With our on-prem products, we have very little data in comparison. And That means that every time we do analyses on our customers, we have to remember that we know a lot more about our SaaS customers than our on-prem ones. But we can't generalize because we're a cybersecurity company. By definition, our on-prem customers are ones who are usually more interested in the security. They are on-prem because they want to control their own data. It means that we have to always be aware of that and understand how we apply our SaaS data to them is going to be unusual at times. We have to check timeframes. Every time I see a data set that begins or ends in 2020, you should always be suspicious. That is one of the very simple rules I follow, but because it's such a weird year. You need to challenge your own expectations of the data. You need to assume that there's something that you don't know. If you think you understand it, you need to question yourself. Try to prove your own hypotheses wrong. And you need to remember that every data set is a point of view. This is, I think, difficult for people who work in tech sometimes to accept. They think, oh, I'm looking at telemetry data. This is just data the app generates. This wasn't generated by a person. Except that telemetry data was coded by someone to be sent. Well, maybe coded by Claude, but hopefully coded by someone. They chose what data was sent, when it was sent, how it was sent. And in doing so, they encoded their own point of view, their own beliefs about the data, their beliefs about what is important into that data set. And if you're not careful about that, you'll just pass those beliefs on without ever questioning them. You need to also understand your audience. I talked about this briefly in terms of those cognitive attributes, the psychology of perception. But more than just that really primitive psychology aspects, you also need to understand their context, their biases, their expectations. People look at their data and they expect it to say something back to them. And if it's not saying what they anticipate, they are going to approach that data set very, very differently. It means that you need to, especially, again, I've worked in finance situations before, if you tell a company that they're not doing as well as they think they are, that's a different conversation than saying they're doing better than they think they are. I say here, clarity is empathy. You need to put yourself in your audience's shoes. You need to understand what they are going to want to get from the data set in order to better make sure that the visualization serves them and helps them get to the truth. You need to understand the point you're trying to make. It's every chart argues for something. If you have a chart and it doesn't argue for something, then I would say it probably shouldn't exist. It's at the same time, a good chart always supports a wider story. You need to put it in the context of a bigger argument. You need to be intentional. You need to understand what question you're answering and why you're answering it. And once you have a good point, once you have a good argument, a lot of the times design decisions tend to come a lot more naturally. As an aside, I'm not sure how many people recognize this. This is the Nightingale Rose. It was created by Florence Nightingale, and she used it as part of her thesis and her argument to convince people that actually hygiene is important in hospitals and people should clean their hands before doing surgery. And as I believe one of the first times that anyone ever used data and data visualizations to change policy decisions on a national scale. Don't ask me what it means or how to interpret it, because the visual language has changed so much. I would say he spent about as much time explaining how to interpret this to people as he actually did argue it. The final thing you need to understand is yourself, your own biases. A lot of the time, the first person you mislead with a bad design is yourself. You need to know how your own perspective shapes what you see in the data, that your audience is going to see things differently from you. And you need to be clear about what the point you want to make is, and then test if the data really supports it. It's a lot of times the hardest person to fact check is yourself, but it's also the first person you have to before you start sharing the data around. Yeah, so this is a quote from Stephen Few that I quite like as well. It's a lot of times that's really what good data visualization is about. It's removing the noise between the data and the meaning. It's well, that's the noise in the data itself, in the minds of the audience you're talking to, in the complicated argument you're making, or sometimes the noise in yourself. It's, yeah, that ended up going a lot faster than I thought it would. I almost certainly have forgotten something. But thankfully, I have a bunch of references, so if you do want more information, Tim Harford's has a really interesting book, How to Make the World Add Up, and also Data Detective, but I actually mostly like his podcast, Cautionary Tales. Alberto Cairo's How Charts Lie was all the major inspiration. Schwabish and Tuft are both reference books that I use when I'm creating charts a lot of times. Tuft was written in the 80s, when a lot of visualizations were done with actual graph paper and pens. But everything he says is still true. Finally, this paper by Funkenary et al., The Science of Visual Data Communication, absolutely fascinating. It goes deep, deep, deep into human perception, how we perceive data, how we think about it, and both how it can mislead people and how we can use it to make people better understand the data they're seeing. Finally, yeah, this is one of my favorite quotes from Tim Harford. It's easy, I think, to talk a lot about how visualization and how statistics can mislead people and think maybe we shouldn't bother. But a lot of times it's important to realize that they are also really good ways of getting to the truth. And without them, it's even easier to tell lies about what the data says. Yeah, finally, that's my LinkedIn if anyone wants it. And I think we have some time, so questions, I guess?
Any questions?
Silence is good.
I guess I have one question,
Yes.
if that's okay. I'm fascinated by the way you can pull out the stories from the data and things like that, and how you can tailor. I understand the visualization
Yeah.
to that. Do you change your approach when you're trying to give that data before give those visualizations before the story? But most companies say, like, we sold this much a year, you see a trend over time, but then the story is the analysis of that. Do you change your visualizations for that, or do you have a way of doing that that's different to the storytelling?
I'm not sure I understand the question.
I'm not sure I know what I'm asking. I guess there's almost like two levels. There's standard visualizations that companies or execs or people have,
yeah.
and then there's ones where you analyze it and you say, actually, I'm seeing something here, I'm going to pull this out.
Yeah, so I guess it's sort of the difference between bespoke visualizations and dashboarding.
Yes,
Yeah.
yes.
Yeah, so a lot of times, when you're telling stories with dashboards, you do have to think about this stuff as well. It's a different thought process. A lot of it is because you have to be a bit more abstract around what stories you think people are going to be interested in. What stories are generally going to be interesting. There's certain ones that always are. Things like sales per month is something that it's always going to be an interesting story to tell or something like that in terms of a business meeting or Conf or for an exec team. They're going to find interesting stories there. So dashboards are like a different beast, to be honest.
Okay.
Because they're interactive, so you need to then consider how people are going to interact with them, what sort of questions they're going to ask. You need to anticipate that different groups are possibly going to be using the same dashboard for different purposes. So I'm generally a fan of having different dashboards for like managers versus execs versus people on the ground, because if everyone's using the same one, it ends up becoming really bland because they all want different information. But yeah, you're right. It's like there's a lot of times we'll have dashboards, people will see something vaguely interesting, and then that's when they'll come to me for something a bit more bespoke. Can we understand why this is happening? What's going on? And I can pull out a more specific visualization to really get to the core of what they're asking. Yeah.
Thank you, and thank you for explaining are making me explainable. Thank you.
No problems. Yeah?
Because visualizations can lead to people misleading what the visualizations tell them, should you maybe avoid using them? And when you use them, should that be accompanied by some text explaining it? Or should you just throw the visualization and leave people to interpret?
I think a lot of times you shouldn't just throw a visualization at someone and expect them to figure it out. A visualization should always be part of a grander story, a bigger argument. It should be used to condense what could have been paragraphs and paragraphs of text into one little picture. There are definitely times where you shouldn't include a visualization. My thinking is, if you can sum up the visualization with one number, then that visualization shouldn't exist. If you have a visualization and you've got nothing interesting to say about it, then it shouldn't be there either. But I think visualizations can be really powerful in allowing people to compare different things very, very quickly, very intuitively. And a lot of the times they can replace what would be a lot of text and some difficult thought processes. Anything else?
All right, if there's no more questions.
Dun, dun, dun.
Hold on.